Okay, continue share. Okay, is that working for everyone?
Yep.
Okay, awesome. 1 second. Okay, so just to share a little bit about myself, I just in addition to that intro, I appreciate that. Thank you. Um, During the full-time day, I am a member of the Army National Guard, so I'm so excited I can come home and flex over to my science naturalist side this evening. And on this topic, we've talked about getting just an intro to biomimicry into this program, and I hope that after you've reviewed this, that you see the connections, like how as naturalists, how biomimicry can help bring people to appreciate what we have and just build that closer, stronger connection to nature. So this intro slide here, I entitled it Biomimicry, What Would Nature Do? Because that's kind of like the whole key here is, rather than, how can humans do it better? Well, what has nature done? What has nature done to be in existence for over 3.8 billion years? And what we see around us is what works. So what better mentor to teach us how to fit in here better in this world and just create conditions more conducive to life. And I chose this octopus picture because of the recent movie there, The Octopus Teacher, and the whole emphasis of nature as a mentor really resonates with me. So that's why I just totally dig that movie. That's another put it on your hit list to check out. So as an overview, the takeaways that I would love for you to leave this presentation with is biomimicry is nature as model, mentor, and measure. I'm going over a introductory, very broad stroke review of biomimicry. There's some key parts that help introduce the whole approach to it, the process of thinking in a biomimicry sense. So those are operating conditions, and then life's principles. Those are deep patterns that are that reveal themselves across all life. There's 3 essential elements. I'll go over some case studies in case you're wondering, well, how do you do biomimicry? What does that mean? How can you show me an example? And then I had a few native species that we could look at together, and I would love to hear what you think their adaptations are, and we can connect that back to how could biomimicry thinking be emphasized in our local creatures. So biomimicry. So what is that? This is it's a fun way to look at nature as I said in the beginning. What's around us has been in existence for since time has began, and what doesn't work is now in the fossil record. So there are so many different ways that you can define this in work of biomimics. Everybody has their own type of definition. It's what is meaningful for you, what works for you, how you connect to your audience. So from um, the primary literature, I wanted to put this definition up here of just learning from and emulating natural forms, processes, and ecosystems for the purpose of creating more sustainable designs. So just to dig into that more, so it's, if you've heard of like biotechnology, biomimicry really isn't anything new. We've been doing it for a long, long time. We just may not always have put that name on it. And uh, it's not just like imitating nature. It's not just seeing like what can you harvest from nature, what can you extract and use, but it's how can you incorporate the lessons of nature and not just use it for a benefit, but how do you create a design that's like regenerative? How do you create sustainable architecture that that creates conditions that aren't taking away from natural resources and creating waste that has no repurpose. So it's looking at that whole picture. That's just what I wanted to emphasize on what is a more sustainable design. Not just that it's cheaper for us to make or that it's just like a cool new technology, but it's really paying back to the rest of the world. What are the effects going to be of your design? So at the core, the forms, processes, and ecosystems. Forms could be something as simple as the shape of a leaf, and how does that help that particular tree or plant better take in sun rays to photosynthesize. Processes, that's just the continual cycles. There's endless examples, just even cyclic processes such as the seasons. And then taking it to the higher systems level of an ecosystem, that's kind of like if we look at it like in our human culture sense, how can we build our cities, our communities, and have them work more like an ecosystem works, where there's this circular economy type atmosphere where things are repurposed. There's integrated design, there's multifunction, and best of all, there isn't toxic residual of what we do. So just to pause there for 1 second, this graphic here, the center, earlier when I was saying creating conditions more conducive to life, that is really at the heart of it being at the center. So innovation, yes, and paying respect to the actual science of how that came about, but the most important part is how does it help us fit in better on this planet that's rare. And as naturalists, we have that innate sense to protect that, and not just for now but enduring. So to move on into Earth's operating conditions, the idea here of explaining this is that life on Earth is subject to these operating conditions. There's no getting away from it. So this picture up here of the Earth and the sun, that we are a certain distance that allows us to have the particular weather that we do. We're in what some refer to as like this Goldilocks zone, that we're just hot enough and not too cold, not too hot, that everything exists the way it does. So everything is going to have to depend on that particular type of energy that we're taking in from the universe. Water, all life requires water. So, and it's also a fun fact I had in my notes here is that all the water that has ever been created is all that we're ever going to have. So I just think that's very special to note. And then this fun graphic here on the right-hand side is representing gravity. So gravity affects pretty much everything. It affects our electronics on Earth. Like if there are cosmic events that affect how our solar, what am I trying to say? I lost my train of thought. How our satellites work, and the whole way that they rotate around the Earth. So there's effects that we cannot escape, and things would be very different if we had a different amount of gravity that is affecting us day to day. So life's principles. So given that we have to exist in this world where there's those certain operating conditions that affect everything, everybody, the life's principles, what they are a set of principles that they express all these patterns that if we really dig into life and how it works and how things adapt to this planet, how those reveal themselves across many different species. So they're not just like, all plants have a certain design. It's things that can be seen across like all species, all sizes, and they just explain how things have come to survive the way that they do. So in biomimicry, these are also ways to evaluate if a design is fitting into those conditions more conducive to life. The main ones on here are listed, those 6, but there's actually about 26 altogether. But just to keep this at the intro level, I would love to dig into more of them. And feel free to ask me anytime in the future if you would like. I can share a list of all of them. So these are key patterns that all life expresses, and they are also ways to measure our designs against. Okay, how is this a sustainable design, or how might this fit in a particular context? So I'll go through the main ones here. So the first one I want to talk about is evolve to survive. So what this is about is that all life is at the core contains DNA, and that has been changing and altering since the beginning of time, from the first uh, creatures at the fossil record all the way until today. And the reason why life has been able to evolve to survive is the reshuffling of these blueprints, so to speak. That's what I like to refer to them as. And um, as time has moved on, what works gets passed on, and what doesn't fades away. So over time, that's why I have this arrow here that's showing how, as time goes on, there's this optimized effectiveness of the way things are designed that has allowed them to continue to pursue and thrive. Adapting to changing conditions. So here, the example I found to use is the example of a forest fire. So there are some species that actually rely upon fire. So rather than something dying because it's been exposed to this high heat, there are certain trees here that they actually need that in order to germinate and to create the next forest. So the ideals behind here are that depending upon what is occurring, that a life form, a design can adapt to things like temperature or moisture, even the amount of light that they're subjected to. And this particular tree in this picture are jack pine cones, and they actually release their seeds from their cones in a response to a fire. So this idea of disturbance, I'm sure that's in a lot of other like ecosystem, ecology type material that we've seen in our program. It is a really interesting key topic to dig into, is how, disturbance, at first it may sound like it's going to, affect things in a negative way, but disturbance is actually positive in many ways. And that is one thing that I'm actually looking at in the military, is how is disturbance on like different training ranges throughout the state, how is that actually helping areas out, for example, helping to press seeds into the ground, or ensuring that certain creatures that may be existing in those areas, that we know that by, if there are certain levels of disturbance, whether that's noise of vehicles or just foot traffic, how that will affect our local ecosystem inhabitants there. The next principle is being locally attuned and responsive. And one thing I want to mention too with these is that these don't have to necessarily also be strictly talking about how a life form functions or a design. They can also be ways that like we interact with each other. We have a whole program. There's many people that have in-depth material on biomimicry for social innovation. So these could also be used in ways to like change the way you make decisions at work, or how your teams are formed, or maybe you have certain ways that you want to improve upon your leadership. So these patterns, it's really cool to dig into it, because they really do make sense, first of all, and they can help improve designs, whether that's physical or intangible, like building a team. So back on this slide here. So being locally attuned and responsive, the idea that there's these cyclic processes that happen, and being able to time certain events according to those cyclic processes, like with seasons or the tidal waves. I like to use this example here of coral. It's this really cool thing happens here. This is from the Great Barrier Reef, where during full moons, the corals respond to that cyclic event by releasing their eggs. And I just thought that was so cool that something so small and so far beneath the water is responding to the reflection of the sun on the moon. So it's in tune with this. And the second bullet point here, that these particular pathways, chemical pathways, are only allowing certain molecules to perform their intended function. So when these corals, they actually are responding to each other, whether it's either sperm or eggs that are being released, and they can only meet one another and reproduce because of those cues. Next, integrating development with growth. So there's this self-organization that happens, and the example of bones is used quite often just to try to show how you're like building from within. There's like this nested component at the very bottom. There's a cell that the like bone material cell, an oocyte, if I recall that. And as your bones grow, especially like in children, they're building upon themselves, and there's this nested structure that as you're getting older, the cells are growing, they're expanding, but then the whole entire human is also growing. So it's like this, I like to think of that as the nested component way of, you're not just getting bigger, but it's also maturing, like the development with growth piece. And there's two more of these. So being resource efficient with material and energy, considering our current ways that we have of like building things and making things, we really don't have a whole lot of conscious thought of like, well, how much does it take to, make new TV models every year, for example, or what is the end effect of when that model is obsolete and it has to go into a landfill, for example. So if a design is resource efficient, it's going to use the least amount of energy to have the most amount of functionality. And when a design is sustainable, there's many different needs that could be met with one elegant solution. So I put a picture here of the cosmos. I just think that is very, to me, I love trying to connect biology and astronomy, like astrobiology, and thinking of how even in space, molecules, are combining together to form planets, and just the way that everything comes together. There's still this efficiency in the way they do actually come together, and then they're still exposed to gravity, and how things that form and things that just are destroyed, like in a supernova, there's this ebb and flow of energy that is it's just a very cool key element of, well, what does it take to put into the system to create this design, and what does it take going out of the system, and how does that affect everything else? The last one here, using life-friendly chemistry. The very basic way to think about this one is doing chemistry in water. There's the example of corals who are actually producing concrete-like material, and they do that at the bottom of the ocean where they're under pressure, and they don't use chemistry like toxic chemical. When we think of chemistry, at least I do, like if it's some kind of caustic, material that may have effects on life around us. So in nature, if there are the combining of elements to build a structure, there's very few of them. We've created a lot of elements, and when we do put them together, sometimes there's toxic results, and sometimes you can't do anything else with it after you've put it together, like some plastics. So this principle is about, there's this, non-toxic way of combining a few amount of elements, and these cave worms in New Zealand, they're able to bioluminesce with very few chemicals and create this chemistry that causes, light to be to light for light to come off. So I I thought that was a cool picture. So this next slide here, the essential elements. So this this part of the biomimicry discipline, the biomimicry thinking, there's these three elements of ethos, reconnect, and emulate. So this is at the core of the program. Like why do we do what we do? How did we get here, and where do we want to go? So an ethos, myself as being in the being in the military, I'm familiar with that word, as having like this soldier's creed. We live by a certain value. So ethos to me, it reigns the same here. That there's these core values that we are a part of nature. We're not separate from nature. That we want to take care of our world, take care of each other, and do it in a way that we have a mutual respect for both our environment and each other. So this like a deep-seated value of why is it important to care for nature, and why do you want to learn from nature? The reconnect. Let me take a drink here real quick. The reconnect element is about, as I was saying earlier, we've been doing biomimicry for a long time. Um, when we look at native cultures, they've been doing this for a long time. How do they fit in with their environment? And they have no need for the built environment in the past and even now. So it's like going back to where we're really familiar with. And for some folks, they're like, well, what exactly does that mean? So reconnection, if we want to think of it as, when you want to go on vacation, or when people get married, they don't do it in an office building, and they don't do it somewhere where there's, black asphalt. They usually want to be somewhere beautiful, and that normally is a natural place. And when you want to go on vacation, you want to be by the ocean, maybe in a forest, or maybe a quiet cabin. So we have this intrinsic, connection to nature, and we feel more, um, can feel more like at ease, peacefulness, and there's just like this a good feeling basically about being in nature and with nature. One way to practice this is also been talked about in our naturalist program, and that's nature journaling. So if you take time to sit and sketch, and whatever comes out, you're in a moment with this particular scene. And many times, if you really take your time, you can learn so much more by that exquisite observation and sketching it out, and maybe taking down questions that you would come back to. Um, Another program there, the phrenology, right? I think I'm saying that right, where you can sketch out how certain plants change over time. That's definitely that would be part of that reconnect, like being in tune with those changes and wanting to learn more about them. And that this last element here of emulate, that's the whole doing biomimicry. So I thought this was a cute way to ask that question. So giving some respect here to a native. So can you give me an example? How do you do biomimicry? So these next slides, I've taken the material that is on asknature.org, and all those are at the end of the presentation as well. So that that database is, you can spend so much time in there. I'm sure that all of us that are in this program would love to do that. And if you have not checked it out yet, I highly recommend you do and share it. You don't have to sign up for anything. It's just available for you to enjoy. And it showcases actual, like technologies, products, biological strategies, and even new innovations that are like in the works. And it breaks it down because not everyone needs to have a science degree. And the whole idea is to make this approachable, that you can understand how did a product get a inspirational aspect to it, and even companies, like how are they trying to be more sustainable. So this site breaks that down in a really elegant way, and you can dig into as much science as you would like to. You'll see when you check it out. So this first example I have here, and how do you do biomimicry? So I'll go over down there in the notes just to ensure you have that too. So if we have a particular challenge in our human designs, and we want to learn, well, what would nature do? How would nature create something that follows those life principles and fits in with the rest of the world? So this challenge here is about ceiling fans. So those are located in many different settings. The more space they have to cool, they get longer, louder, and that takes a lot of energy to power them and to make them. So this company, Sycamore Technologies, they modeled their ceiling fan after a sycamore tree seed. So I think a lot of people would be familiar with, if you've seen these before or played with them as a kid. They do like a helicopter motion, and so they do that without there's no motors, and there's just this single curve that, as it falls through the air, because of the shape, it allows it to do that rotary type motion in an elegant way. And for the seed, it helps it travel farther and use the least amount of material to get to the ground and start the next generation. So I would love to get one of these in my house. I've never seen one that has just that single blade like that. So that is the story of trying to make a more energy efficient, less quiet, and sustainable design for a ceiling fan. So that's the kind of outline rhythm that these case studies will have here. This next one that I pulled out, I'm so fascinated by pitcher plants. So these plants, they capture their prey by having a very sticky film along the rims of the bottom there, underneath the top like flap. So that substance is very sticky, but it's just a thin film. And when insects land on that, they end up slipping down. They don't have any way to get any friction or traction, and they go down into the bottom of the plant, and there's digestive juices. So that is how that particular plant has adapted in its environment to capture prey in the least energy way possible, but the most energy efficient, getting like enough nutrients. So this company, Spotless Materials, they developed a spray that actually coats a surface, and because of the particular properties of that, it keeps it from having to be like cleaned as often or like disinfected. So the idea this company had was there's so much water and chemicals that are used to clean surfaces. So maybe there's something that could create, a particular layer on a surface and end up having to use like less water and chemicals to clean it. So I did put just a few videos in here. I'm hoping that all is well, and this short little video will play. Let's give it a moment. Everybody hear that?
There's no sound. I think you have
No?
to.
Did somebody have a?
When you share, there are two
Mhm.
boxes.
Yeah.
When you select what you want to share, when the pop-up window comes up, there are two boxes you have to click on for the audience to hear it.
Yeah.
Okay, share sound. I think I've done it. Thank you very much. Let's start over. How about now?
This carnivorous
You're good.
pitcher
Yes.
plant has a particularly gruesome party trick, a highly slippery outer rim which causes insects to slip into a tube full of digestive juices. This super slippery rim, called a peristome, consists of a micro-textured surface which becomes incredibly slippery when it gets wet. This microtexture is formed from overlapping epidermal cells, which cleverly directs insects to slip inwards and not out of the plant. Now, a company called Spotless Materials is designing its own coatings that mimic the slippery nature of the pitcher plant. This coating features tiny nano hairs, and these hold a thin layer of lubricant which mimics the presence of water on the pitcher plant. The company calls this technology the Liquid Entrenched Smooth Surface, or LESS for short, and it can easily be sprayed onto a variety of surfaces. Because LESS coatings make surfaces very slippery, it allows them to stay cleaner for longer, as they naturally repel fluid, dirt, bacteria, and even solid waste. This is particularly useful for things like solar panels and camera sensors, but also for reducing the harmful effects of using toxic cleaning products. It's even been used to create super slippery toilets, which repel human waste and save vast amounts of water. Thanks to the pitcher plant-inspired technology, these coatings have the potential to save billions of dollars in cleaning costs for all sorts of surfaces, which is great news for the planet, unless you're an ant.
So there's no limit to the possibilities. I thought that last part there was very significant. There's so much water that is used, and again, all we have of water, or all the water exists. That's all we're ever going to have. So that would be paying dividends back to reduce that and reduce the amount of chemicals that go into the water and cause the myriad of issues that we're all probably likely familiar with. This next example case study is called Ornilux bird protection glass. So I really enjoyed learning about this particular case study because it actually is a feature of what I would call spider technology. So there are certain spiders that have UV webbing and that they incorporate into their webs, and not everybody can see it out there in the natural world, including us. So the reason why the spider has this adaptation is to one, to attract insects, because they're actually attracted to that, and then two, birds can see the UV rays or UV lines, and so they avoid crashing into the webs and causing the spider to do more work. So this particular glass, this is what it looks like here on the right hand side. And the idea behind this is to prevent the millions of birds that die each year. I feel horrible sometimes when I don't close my screen door and I see a dove smash into my sliding glass door. So just think if this was like a requirement for all buildings, for example, how much that would help another creature not have to suffer. The next one here, I have another short video. This is called PAX Technologies. This company is just really amazing. They're featured in the book by Janine Benyus, who is the founder of Biomimicry, and is just a very amazing person to listen to, and inventive and innovative. And this particular technology is about what I read as rotary devices. So this image here on the right hand side is the image of a rotary device that's in water tanks. And so the idea is that these tanks have to keep the fluid circulating, but the methods to do that, it's loud and it takes a lot of energy. So what out there in nature has this similar type requirement where it has to spin, and because nature follows life's principles, what uses less energy than what these fan blades do. So I will go ahead and play this video, and these are all less than 2 minutes, and I think this one's pretty enjoyable too. Hopefully that last one was. Okay. Are we good on sound?
Einstein said that essentially for something to exist, it must be moving. So every single thing in this universe is moving. The interesting thing is that all of that movement in nature has a particular spiraling path. Nature never ever moves in a straight line, no such thing. So that is nature's streamlining principle. When I froze the whirlpool that you see in your bathtub, you pull the plug out, there's the whirlpool. If you freeze that whirlpool, it's exactly the same geometry as a hurricane or a tornado or any other spiral, a cochlea of your ear. This shape is archetypal in nature. And so when I froze this, I was then able to rotate it and create. Because I had a frozen whirlpool, I was able to create a whirlpool. So one of the first things that I used it on, particularly in America, there are great big holding tanks. Well, that water gets stagnant. The municipalities that manage that water have to put chlorine and chloramines into the water. The problem is better solved by mixing that water. Generally throughout the world, if you want to mix water, it's very expensive. I put one of these frozen whirlpools in the bottom of one of these tanks, 6 inches high, 4 inches wide, and I rotated it with a couple of 100 watts of power, a couple of light bulbs of power, and I found it was able to mix an entire tank of water, 10 million gallons, which from an engineering point of view is not even conceivably possible. So from there, I started adapting these shapes into fans. Fans use 18% of the world's electrical energy. They're not terribly efficient. We found time and time again we could take the best fan in the world and reduce its energy by as much as 30%. So pretty much everything in an industrial world can be improved by taking these shapes from nature and reconfiguring what engineers build today.
I was just in awe after I saw that video. It's just amazing. If you think about the dimensions that he said and how much water it mixed, these are the lessons that can be drawn from something as simple as a tornado spin. This next example of the case studies is called Appeal from Appeal Sciences. So in this theme from the last one, like how much is being, how much energy is used in our day-to-day environment. So I think about often, like if I buy a lot of produce and if I don't use it, like I try really hard not to do that because I feel really guilty. And across many different nations, it's a problem of how to, one, when you produce so much food, this on our mass production methods, and then trying to distribute it and getting it to the customer before it gets rotten, or even when you individually bring it home and you're trying to keep it for a certain amount of time. This idea here is trying to get away from things like saran wrap, or always thinking that you have to throw everything in the refrigerator, or even if something is sitting on the counter, how can we replicate the way plants take care of their tissues, so to not dry out and also to be able to expel some of that extra moisture. So this company looked at the technology of a plant cuticle layer. I'll go ahead and, oh, I can't play this one. Well, that's not fair. So sorry about that. I guess maybe something happened with that link, but what the video was showing was just how this particular company created a product that it sprays onto produce, and it helps develop this layer, a cuticle layer, that it just helps them to breathe, as I was saying. And the idea is to reduce the amount of waste that happens if if it's not stored properly or when it has to be shipped long distances and under various conditions. So sorry about that. I can get that reposted later. So here's a example from our local ecosystem, the Morpho butterfly. So the company Lumichrome, they created a technology that assists with counterfeiting. So in the Morpho butterfly, the color, that brilliant blue, it's actually not a pigment. The way we see that blue is it's actually due to the structure of the wings, and it's a matter of how light is reflected off of the wings that causes us to see the blue. In insect collections, if you do have one of these, it'll be brilliant blue forever, basically, because it's not like a pigment that would fade. So I thought this was an interesting way to emulate that technology. So there is a optical film that actually would change the different views on products because of the angle that you're looking at it. So replicating like that refraction that happens in the structure, the microstructure scales on the butterfly. So just another example of, how could a butterfly, affect something like cryptocurrency or something, needing to prevent, counterfeiting. It's just I wanted to emphasize there, like the possibilities, it's never going to be linear with biomimicry. There are applications for every discipline, every type of, how do you want to make a design better. This next example is about the cone snail. So this particular marine snail, its venom that it uses, it has a whole ton of chemicals in it. I think I noted down in the notes that it's over 200 chemicals are in its venom. And the venom works by paralyzing and immobilizing its prey. But the thing of interest about those chemicals is the particular insulin. It actually, the way it immobilizes its prey is that it causes the insulin levels to go to such a level that the prey has hypoglycemic shock, and that's what makes it become immobilized. So for the human challenge, there's millions of folks that have type 1 diabetes. And so the insulin that's manufactured to control their blood sugar, it has two different types of components to it. And because of the way our bodies metabolize that manufactured insulin, it can be difficult for folks. I witnessed this with my own dad, of trying to predict, okay, when you take a dose, and then, down the line, if you took it at the right time, and just trying to adjust to that. So the insulin chemical component in the snail's venom, it doesn't have a particular, I'll just call it a component that causes that delayed reaction. So it like helps to get to work right away, basically, is how I like to understand it. And just think of what that could mean for all the millions of people, and even kids that have to control their blood sugar. So rather than having a manufactured product, this type of technology could assist millions of folks, and it's all about life-friendly chemistry. I could do a presentation without including one of my favorite animals, the elephant. I hope this video is okay. So this case study is called the Bionic Handling Assistant from the company Festo. They looked at the need in factories to develop a safer environment for humans that maybe they can't move as fast, or there's very precise steps and processes going on in a manufacturing line. And so this company looked at an elephant's trunk as a way to replicate a like bionic arm. And I didn't realize this until I dug into this case study. I didn't know that there's no skeletal structure in an elephant trunk, and the way it has its what do I want to say, like the pliability, the way it can manipulate items uh, of many different weights and sizes. It's all about these muscle fibers that act almost like a fluid, as a fluid that's under pressure, and that gives it its ability to have a wide range of motion, and then also being able to pick up and do these very fine, motor skills with the end of its trunk. And I'll go ahead and play this video now. So this one, there it goes. This one's pretty quick. So this video is just showing the design structure of the robotic arm. There is no volume on this, just to let everybody know. So this particular design, it replicated those 3 segments within the elephant's trunk. And then these chambers, those were mimicking those muscle fibers that I mentioned, and how they are under pressure, and then how they're able to move in all these different ranges and extend and contract. And then that's replicating the end of the trunk. So this has that motion where it's able to rotate and then also grip at the end. So moving on to the last case study here. I'm a huge fan of cicadas. I love it when they come out. They're incredible. I've done a little 90-second naturalist blurb on them before on a blog. The idea behind this particular deeper look at cicadas is about their wings. So this is from the University of Illinois, the Urbana-Champaign. The idea that their wings, they have this particular property where they stay clean and free of dirt, because they have these very microscopic structures that look like tiny little, I would call them like mountaintops basically. And because of that structure and how far apart they are, they're able to deflect and prevent water or dirt from sticking to their wings basically. So this company was looking for a way to do manufacturing of, like mass manufacturing of parts that have these very same like micro details basically. And so they were trying to figure out how to do that to scale without losing that particular, the definition and contour. And so the way they did this, they took the cicada wing, and they used a process that is called nano imprinting lithography. I won't pretend to know exactly what that is, but what I read was they took the cicada wing, they applied a particular substance to it, they overlaid that with a polymer that caused some of the metal type elements to remain as like a imprint of the wing, so that they could take that and then use that. I believe you could apply it to like digital printing technology. So the reason why that works, or how that makes their manufacturing process more efficient, is because the current ways to replicate surfaces with those type of structures is very costly, or it's very labor intensive. So in this particular case study, it's helping to improve that process, both energy wise, less toxic chemicals, as with so many manufacturing processes. And it all was inspired by this little cicada's wing. So on this next slide, I would love to hear from you all. I don't know if we want to do just like a take the mute off. Feel free to chime in. So looking at some of the native creatures here of Arizona, I put a few on here. I've had some particular run-ins with, and what I wanted us to look at was, in this idea of looking closer at the reasons why things exist where they do and how they do, and then if we want to, we could put a label on that as their adaptations, and then further unpacking that. Well, if this is how this particular creature organism has adapted, then what's the lesson that we could learn from that? There is no right or wrong answer. There is so much discovery and application, and sometimes it's the opposite application that you think it might mean. So starting off with the bark scorpion, this time of year, I think it's actually started in April, now I think about it. I have quite a few run-ins with these in my apartment, and it's a love-hate relationship. I don't particularly like to kill anything, but I don't want to live with scorpions. Can anybody throw out there some adaptations that you think that the scorpion has to living here in Arizona?
I know one of them is negative geotaxis, which means that they can walk upside down. They can walk on the ceiling.
Wow,
And they
that
have
sounds really cool.
a waxy substance on their exoskeleton that helps them repel heat and sunlight.
Very cool. That's why I use my black light to find them.
Mm-hmm.
Anyone else?
Yes, those ones do glow. Sorry, Diana asked if those glow.
Oh, no problem. Yes, they glow very well, and even their exoskeletons do, because sometimes those kind of catch me off guard.
Right.
I say the jackrabbit's ears. Oh, well, you want us to share an adaptation? And then,
Yeah.
Anything.
oh, well, their
Go for it.
ears are an adaptation for the jackrabbits. Their large ears help them stay cool in the hot desert.
Yes.
I love it. Yes, like as they're sitting there and grazing, they don't have to worry about getting hot. Everything is, there's evaporation happening that keeps them cool while they're close to the ground where there's a lot of irradiated heat.
And then I think I'm double checking something.
Okay. Going back to the scorpion, I dug into their venom because to me, I thought first of how their venom is their adaptation to to capture energy, and there is research on their venom looking at how as a chemical how it affects particular pain receptors. That's how it immobilizes prey. So there is research on how particular components may block pain receptors in our body. So where it may be a very significant event to get stung by one of these, there may be a point in time where their venom actually helps people feel less pain when like nothing else works and you're not able to take certain medications, or you don't want to take an addictive medication. Did you find what you were looking for, Mariah?
I did, and I was wrong.
Oh,
So
okay. Well, I'm sorry.
To double check and make sure. I had heard of something. That's why you always fact check. So I did, and I heard wrong. So, or I'm remembering wrong.
Oh,
Either way.
No problem.
So Mariah, is it that you heard wrong or it's a misconception?
I heard wrong. I was under the belief that Palo Verde beetles were carnivorous. And so I was looking to see if maybe that was perhaps why they had such long antennas, but they are not carnivorous. They eat fruit and nectar.
Gotcha. Thank you.
You're welcome.
the first time I encountered one of these, I did not know what it was, but I was fascinated because I have an affinity for insects, and I tried to capture it, and it was a little bit difficult because they have, you know, like most beetles, they have two little hooks on the ends, and I didn't know if it was going to have like a really bad bite or sting. I didn't know what this thing was going to do, but I managed to get a hold of it, and yeah, those antennae are really cool to look at up close. There's so many segments, and what I learned about them is that they spend most of their life underground here, and being called a Palo Verde beetle, they live on the like tissue of the roots of those trees, and the only time they come above ground is to find a mate. And usually, from what I had gathered and reading about them, was that happens during monsoon season. So they're like signaled by the rain to come up above ground, and then their sole purpose is to find a mate. And they're they are really huge. If you have not seen one of these before, I want to say they're probably about 4 inches.
Yeah,
I want to
they're-
estimate.
I have one I preserved in resin, and yeah,
Cool.
they're good 4 inches or so.
Yeah, whenever we find dead ones, like we get them in the pool all the time.
Yep,
So
yep.
if they're
Oh,
dead,
wow.
my
That's
son
where
collects
we-
all the dead ones.
Yeah, that's where we would find them too, in the pool and dead. And so we preserved the one in resin, which is it's kind of cool.
Yeah, I
Um,
love resin.
That is cool. Thank you for sharing, guys. The last one here for the Gila monster, there was a theme of insulin in these case studies. So I had not known this before, but thinking about where the Gila monster lives, and how that creature is low to the ground, I don't think they move too fast, and their chances of coming across food is not, it's not very frequent. So when they do get something, they could eat a lot at once, and then there may be that time in between before they can get something to eat again. So in their systems, they have a particular type of insulin that helps slow down their digestion by a lot, and it helps keep them from getting low blood sugar between those times when they're like not able to find anything or not capture anything. So it's like slowing their metabolism in a way where they can sustain themselves. And I never known before that was something that's how they actually did that. I've heard of how certain animals don't eat anything, or they eat something at a very like small frequency, but now just learning that it's because of this particular component in their saliva and their digestive system that helps them to do that.
Very cool.
So looking just at these, or if there's any others that that pop in your mind from Arizona that resonate with you, if you think about how could you look at the way they adapt to where they live, and how might we take a lesson from that, and maybe it helps us live in such a way where there's like less energy involved, or you're making more use of the resources that are available to you. You're not using above and beyond what is needed for you to survive. And the way that they take their cues from the environment as well, that's another lesson in itself. Like the whole in our program, it's the antenna versus the signal response. How those reactions cause different processes to unfold. So this whole idea, I try to keep this like not too much nerd. So hopefully that was the right amount for everyone. And if you do go on to asknature.org, they've laid this site out. It's like evolved in itself. It's got a life principle of its own, and it's very easily organized, and you can just read through very quickly. Like each one is a very quick read, and then if you want more, there's some tabs where you can look at primary literature or other case studies where there's a creature that's like got a same kind of function or different design that was being looked at. And it's just I can't stress enough how much, if you take the time to check that out, and it could be for just for a pleasure, or in your work that you do, or if you in teaching others like how to get more more into embracing like learning about science, because there are some creatures that, for example, that Palo Verde beetle, that it's probably not very, you know, attractive to some, but maybe a jackrabbit is, and you can, you know, tailor that to your audience. So I would love to leave you with that inspirational type thought process. So this what if, you know, these are just a couple of things I threw out there, and the idea of how far and wide and deep that this kind of thinking could go, like how much it can, you know, affect, you know, things like your family, your community, your culture, you know, us as naturalists, how to better connect with our audience and the folks that we interact with. And we're asking to get more connected to these different places by, you know, going out and doing various activities, whether it's, you know, tracking changes from the seasons or doing cleanups. It's, you know, just building, to me, this ties into that stewardship and citizen science aspect. So from the beginning, if I leave you with anything, it's, again, I want to say it as biomimicry is nature as model, as mentor, and as measure. So the model, that's about having these aspiration ideals, you know, what is possible. And as for mentor, it's this whole, you know, encyclopedia nature that's available to any discipline, any level of interest. And then as measure, how can these lessons that we learn, how can we take them and then, you know, use those life's principles to see how is this going to sustain us and also create conditions more conducive to life. So if you do want more biomimicry, I put a couple of links on here. There again is asknature.org. And here's just a few links to the case studies that I mentioned. If you wanted to dive deeper into those, that's the whole, how do you do biomimicry? And thank you. If you do have the time, I would love if you, I believe I shared, I could put this in the chat, this little link. It's just a little 1-minute survey to tell me what you thought of the presentation, any feedback that you would like to share. And then there's my email address. I'd love to. Oh,
I'm sorry.
okay. Put it in the chat.
Yeah, if you copy the link and put it in the chat, then we can use it.
Okay, I think so. If I stop sharing, I think I can go to the chat because I don't see it anywhere.
Yeah, it's hard when you're presenting. The chat doesn't show up very well. So can you send me that slideshow so we can share the links that were on there and stuff?
It's 37 megs because of that the videos. So I thought maybe I could put it in the shared drive.
Yeah. If you just want to dump it in the Google Drive, that's fine. Maybe share it under the I think the advanced training folder. I have some presentation, so maybe stick it in there.
Rachel, you can just copy them, plot them in a Word and send them, because that would be.
Yeah, or if you want to send the links out, just the links, that's fine too. Whatever.
Yeah.
I can do that. Yeah. But thank you all again. I popped that in there, and if anybody had any questions, I left a little bit of space here at the end, and fire away, please.
I don't have any questions. That was just a great presentation. I've always loved biomimicry and you did an excellent job.